So let's see. Yeah, sure.
But then it still becomes that word positive.
Okay. So what do I do here? Technically, both parts are easy to integrate, but I almost never want to make my polynomial dv. But if there's a natural log in there, if I put natural log instead of sine, then I would let my polynomial be dv. Does everybody understand why I don't want to, in general, make my polynomial part dv? Why?
It's bigger.
Because when I integrate it, it gets higher power, and normally it's the fact that there's so many of them in there that's bad. So if we make more of them in there, that's worse. Okay. So I'm going to let u equal x squared. So du is 2x dx. dv must then be sine x dx. So then v is negative cosine x, yes. Right, changing the gears on trig functions when you're integrating versus differentiating. It's a little tricky sometimes. So then I get, what do I get?
X squared times.
Yes, so negative x squared cosine minus,
Negative cosine.
good.
Cosine x sine dx. Sine x dx.
No,
Oh,
2x.
v du.
oh, wrong one.
Oh, yeah.
2x dx.
Yeah.
I get confused with the V for the use wrong one.
Yes. And let me say a little word about that. If your u's and v's are even worse than mine, which is, there's not much room there to be worse, but you could use other letters. U and v are dummy variables. I don't give a shit what variables you use, to be honest, right? You could use m's and p's. I don't care. You guys kind of with me? And if you've done any of this work, you know that sometimes when you do by parts, part of it could become a u sub. And it really sucks when you've already called u something and you don't want to use u again. So, all right. How do I do this? Let me clean this up a little bit. Do you all agree that this integral is better than that integral?
Yeah.
Why? Why is this integral better than that integral?
Because you have to just use it.
It's got less x's in it. The whole reason, if those stupid things weren't there in the first place, that integral would kick ass. Yes? So it makes sense that the less of that extra crap is in there, the better. It still sucks. But how do I do it then? So now I'm focusing all on this. I could have given you this problem at the beginning. Yes? And you guys are in calc too. You've seen this shit before. In the middle of a problem, another problem breaks out. Right? It's like watching hockey. In the middle of a boxing match, a hockey game breaks out. So, how do I do this?
Your u is an x.
U is x, du is
dx.
that's crazy, and then dv is cosine x dx, so then v is sine x.
That's crazy.
It's insane. It's barely sane. So then I get, this shit just comes for the ride. By the way, there's a process where you can do all the derivatives at first. I highly recommend you don't do that because invariably it almost always gets put together wrong. So I don't blame tutors for showing you this. I don't know if anybody's seen this, where you just kind of do all the derivatives and then you put stuff back together. Yeah, so if you're really careful, it works and it's quicker, but there's something about rewriting it and seeing exactly why you have to do more. Also, it's almost always the negatives that mess people up, but sometimes people just put stuff back together wrong. So it just depends on yourself. If you're able to follow it carefully, not a damn thing wrong with it. Yes?
Will you accept the tabular method on the exam?
Hell yeah.
Oh yeah, let's go.
Yeah. But if you make a mistake,
Oh yeah, then that's not me.
yeah. And then if, anyway. All right. So then this, I got to be careful, there's a 2 in front. So this becomes uv minus the integral of v du. Now that is awesome. Is everybody with me? So there will, of course, be situations where I have to do repeated applications of my parts. It just depends on what my integral comes out to be in the first iteration of my parts. Blah, 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 blah. What else be? There we go, Jeff.
Bless you.
Whoops, yeah, bye-bye. Okay. Is that all right? Anything else from homework stuff? So obviously that's not the exact same. In fact, the problem you have in your book is easier because E doesn't have a change of sign involved. Okay. Okay. If there's no other questions,
Oh.
yes?
45 from 7.1.
Ooh. Now this one says first make a substitution and then use integration by parts. Okay. I would argue, well, okay, let me see what you guys think. What's the substitution that they're talking about? What do you think? What part of that sucks the most? Normally, if I cover the polynomial piece, and that's polynomial in theta, yes?
Mm-hmm.
It would make it better. Does that make it better?
No.
No, it makes it worse. Yes? So what is the worst part about this integral?
Theta squared and
Theta squared inside the trig.
in the cruiser.
Can we stop for a minute? You guys see that? Alright, so what kind of substitution do I want to make then? Use some. Now, let me see, who asked that question? Is there a specific step that you got stuck on, or was it the beginning? Who asked that question? Sorry. Yes, I'm
It was just here's the wording. You said
Oh.
going with that measure.
So try that U sub and see where you end up. And then see if it makes sense what they're saying. And I might disagree with what they're saying, to be honest, but we'll see what you guys think. Is it? Please tell me that's blurry. Oh, okay, thank God. I'm like, I don't know if you guys noticed, but like, I have like 20% of my vision in this eye, which is why I couldn't see you. So, I lost my vision in this eye like in 2019. It just went, right? So it's like looking through your shirt, basically. So like, now I've got depth perception, so if you hand me something, I can grab it, but the first semester after that happened, somebody would turn in their homework and I would be like, okay. Or they would sneak up on me during a test, I'm up there, and like, Mr. Walton, oh my God, because I can't see that way. Sorry. So when I saw that was blurry, I'm like, come on, man, I got my one good eye, don't tell me that's going. Okay. Anything else? So try that step and see what happens after that first use of. For that number 45. Be really careful about the limits also. It's a definite interval. Yes.
Can you also do that without doing the use of first? Because that's what I did for the counting variable instructions, right?
Without doing the use of first, what did you let u equal? If you did, so you did by parts immediately?
Yeah, I did by parts, and I said u equals x squared, and then dv equals x cosine x squared.
Wait. Oh, you made your theta's x's. Okay. Oh yeah, sure. Because if you break it up into theta cosine theta squared, then u sub works directly on that. So that's where I said I might disagree with their instructions, because there's other ways to do this problem. So if you end up not doing exactly what they say, you're fine. Because there are other ways to do this problem. Yeah. Okay, let me stop for a minute. Okay. Anything else? Yes? 68. Oh, yeah. Sorry. This is really evil for my 180 class because we actually didn't finish this. So 68, treat that like a little bonus question. That's fine. I was just trying to keep did most of you guys do cylindrical shells? Does this sound familiar? Okay. Just treat that like a bonus question. That's fine. I just kind of wanted to keep it alive a little bit. And then, I don't know, I'm also very evil, so I wanted to, like, for those of you, like, I escaped that. I'm like, no, sorry. So treat 68 like a bonus question. That's fine. Okay. Try it if you can. That's from section 6.3, if I remember correctly. Cylindrical shells. 6.2 was washers and discs. Anything else? Okay. All right. I want to point something out. Let me see. I'm not going to load it. In Canvas, I opened up a module that's got handouts. So all the handouts I've given out so far for Chapter 7 are up in there, including one I didn't give out. And they didn't want to, well, I did want to print it, but I ran out of paper. I didn't have time to go get some more. But it's up in the modules. There's a handout section for Chapter 7. There's a handout for trig intervals from section 7.2. What did we say trig intervals really were? Why did I not like that they made it its own little section? Does anyone remember, right? We could have taught that in 1.8. Do you guys remember why? What are trig intervals? Let me start there. This is what we did last time. Here, I'll give you an example. What have I done? Oh, good Lord. A trig integral is something like, you could do it, Jeff. Yeah, let's do this. Yeah, I like it. So this is just really a use of problem, right? This is really just a use of problem. So I kind of don't like it when they give something its own section, when it's really just a certain kind of problem we've done before. So like linear approximations are really just tangent lines, and then you put stuff into them. Can somebody see why I don't want to let u equal tangent here? Very quick, yeah.
Because you have secant tangent right there, and that's the derivative.
Well, even worse than that. If I let u equal tangent, what would du be?
Secant squared.
Secant squared, and do I have two secants to play with? No, so I can't let u equal tangent, so I have to let u equal secant. Yes? And then what's du?
Secant tangent.
Secant theta tangent theta d theta. So if I break this up so that I have my secant tangent next to my d theta, then I've got my du. And then I can see what I have left to rewrite or to take care of. We let u equal secant, and I have a tangent squared left. How do I make those work together? No, I got you. I like the.
I mean, I'll do.
You're good. You're good. Anybody? I really want. If I'm going to let u equal tangent, then this would just be u squared. Yes.
Right.
Yes. What is this? Why did I put all this stuff together? What is this?
Du.
This is du. This is du. I have to take care of tangent squared, meaning I have to replace the theta expression in terms of u. But u is secant. Why is that not an issue? How do I rewrite tangent squared?
Secant squared minus 1.
Secant squared theta minus 1. You guys with me? So, you have to know your trig identities. You have to. I'm pretty sure I put up in our Canvas shell the trig laws.
You did.
I did?
I think you did.
Okay, maybe. Let me stop for a minute. Some of you guys are looking at me, deer in the headlights. You have. I can't say this enough. I cannot stress this enough. If you haven't already noticed that Chapter 7 has a lot of trig in it, it has a lot of trig. I'm doing a trig workshop today, but it's only 30 minutes. It's going to be a very quick, just nuts and bolts, just the really important stuff. But I am going to talk about how you have to memorize less and build more. Because you only have so much room in our heads. Yes? Okay. This is secant squared minus 1. Holy shit, Jeff. There we go. This is du. This is u. And now it's easy, right? Now it's polynomial in u. Yes, sir?
Sorry, where did the tangent squared theta come from in the first?
Oh. How many tangents do I have up here? So I took one of them so I can create du, and that left me with two of them to take care of. I just took one of the tangents and put them over here. See? I had three, so now I have two because I took one of them over there. Yeah. So this idea of reorganizing your integral, all right, listen. If your instructor taught you to solve for d theta, I won't say what I want to say, but that leads you to really simple mistakes. It's so much better to force yourself to find du in there, and that tells you that approach will work. If you just solve for d theta, you sort of don't even think, you just sort of like brute force. And then you get stuck with a theta left inside, and people normally just ignore it. They're like, if I just pretend it's not there, maybe everything's going to be fine. I don't know if you guys are really with me or not, but did anyone have, like, right here, you would solve for d theta? I need you to understand, it's not the end of the world if you do that. It just opens the door to some really silly little mistakes. Is everybody cool that from here this should be easy, yes? Okay. So that's 7-2. It's really just U sub. The handout that I put up in Canvas kind of drills down to what do you do if the power on this is odd? What do you do if the power on this is even? But to be really honest, I don't like teaching it that way. But if you're like really kind of lost, you can look at that sheet. It should help you at least get started on some problems. Are you guys with me? So, okay. You have to know your trig identities. You have to know your trig derivatives, obviously. And whenever you're doing a substitution method, you might pick the wrong thing first. Oh well, that's part of the process, right? So in this problem, you literally just have two things you could pick. If one doesn't take you anywhere, you try the other one. Okay. So anything from 7-2, because I'm about to get into 7-3. I know, it's crazy. Anything else from 7-2? Okay. So just to give you an example question, I know you could ask. Oh, sorry, did I miss something? Yes?
I was gonna ask for that final answer, with the du and that second theta, tangent theta, they would just cancel?
Where are we at, sorry?
For when you, oh, there it is, okay.
So this is du, and this is u squared, and then you just integrate, and then you just replace u. Is that cool? Yeah. All right. Anything else about trig integrals? Okay, you got to get in there and try them out if you haven't done so yet. How many guys have been by the Sissel? Not just because I took you there, but by yourself. Okay, a few of you guys. Trust me, it's just silly. It just makes so much sense. I mean, you literally could go up there, do your homework, and then leave, and never talk to anybody if you didn't need to. And we're all human. We're able to do things better if we know there's somebody nearby that could help. That kind of alleviates some of the pressure on ourselves. And so you might go there and not have to ask anybody anything. And we don't, that's fine with us. We don't care. We'll come by and say, are you doing okay? And you're like, yeah, man. The used car salesman, but you know. All right. Just because. What do I do if I see this? Besides run away screaming. I have to rewrite it, yes? Yes. And real quick, do you guys all see I cannot integrate that? Does everybody see that? I always get somebody tell me that the answer is 1/3 cosine cubed. I want to really address this directly. Does anybody see the issue with saying it's just this?
They just raise the power.
What's the only function that acts that way? It's the only function that's got that rule to it. Polynomials. Is this polynomial? No, it's going to be much worse than that. Do you see what I'm saying? You can kind of understand somebody's hopeful, right? I don't blame you for optimism. Optimism's good. But if you're overly optimistic, it leads to bad days. So what the hell do I do then? If that's not the answer, in fact, doesn't it feel like the answer should be really trippy?
Yeah.
A little bit more involved? Because what do I take the derivative of to get cosine squared theta? Weird shit. Okay. In fact, yeah, that's fine. Get away. So I know there should be a sign involved somewhere, for example. So there's several reasons why this can't be right. The most fundamental is you've applied a polynomial idea to a non-polynomial function. Okay, so what do I do? Does anyone remember? Do we have an identity that might help us? Does anyone remember what it is?
One plus cosine of 2x over 2, all
Okay.
for 2.
So cosine squared is 1 plus cosine 2 theta over 2. So let me show you something. To be really honest, I barely have this memorized. And sometimes I'll even start to talk about it. I'm like, oh shit, do I remember? And what I do is I have this shit memorized. I have to start somewhere. And this shit I have memorized as this. And then from here I can build. This would be 2 cosine squared theta minus 1 if I replace sine squared with 1 minus cosine squared. You guys follow? So what I really hate is letting you believe you have to memorize each trig identity by itself. That's insane. Most of them are linked with other ones, so I can build from stuff. So if I just solve for cosine squared, I get this. So if I forgot this, I could build it. I have to know something though, obviously, so I can mess with it. So I kind of start here. I got to know my double angle formulas. And they lead to several things. They lead to half angle formula. They lead to power reduction. They all come from the same stupid thing. So I'm not going to memorize 8 things. I'm going to memorize 2 and then build. Because that's how much room I got in my brain. Okay. So if I replace this here, does everybody understand how that becomes eminently integrable? Just to say a really weird phrase. Are you guys really with me? I think I told you guys in this case I would take the 1/2 out front just to get the fraction of shit out the way. Okay, maybe. Potentially. Okay. So this would look like Jeff. And then how do I integrate this? Theta
No.
Plus sine.
plus.
1/2.
And if I do this, I know I'm wrong because its derivative would have a 2. I want to kill the 2, so I put it over 2, or put a 1/2, yes?
Plus
Yeah, plus c. And then I get 1/2 theta plus 1/4 sine 2 theta plus a blah, 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 blah. Okay. Make sure you guys are cool with that. So if you need to, you got to review your identities. I'm pretty sure, I got to double check. I'm pretty sure I put the trig laws up in Canvas. It's a green sheet of laws. There's a dark black line. I'm going to assume everything above that line you know. Which means I could put any of that shit I want to in a quiz or a test. You with me? Anything below that black line, you don't have to memorize. Most likely because I don't have it memorized. I'm never going to make you memorize anything I don't. That would be evil. It's like that PE teacher that couldn't do 1 push-up. And it's like, dude, like, you do 1 first. Okay. Okay. So what have we done so far? We reviewed U sub. We got by parts. By parts is insane. It just immediately expands our abilities so many times over. It's crazy. If you've done some by parts, you can see they sort of get messy if you're not really good at repeating. So you want to be really careful with putting everything in the right place. Trig integrals are really just specific applications of U sub. So they're nothing new. Okay. Today is new. Today's going to be some new shit. So today we're doing something called trig substitution. And of course, we'll affectionately call it trig sub from now on because substitution just takes too long to say and write. This is some trippy shit. This is where I love this so much. Because the way I see Calc 2 in Calc 1 even, when you get to U sub, I like to push U sub a bit to show you the flexibility in U sub. Remember when you let U equal X stuff and you can solve for X? That's the first kind of line of flexibility that it's okay if a student doesn't realize that because you don't know what you're allowed to do. Trig sub is so counterintuitive at first. You're like, let me make everything look worse and then hope, right? So, here, just go with me for a second. Little prereq review kind of stuff. If I have this, you could do it, Jeff. Yes? Can you guys just take a second and figure out what this is? So we got function notation, we got substitute, we got all sorts. So just throw a 3-side data in there, see what you get. I want you to simplify it as much as you can. Any questions on what I'm asking you to do? Like, does everybody see what they're supposed to do here? Okay, go for it. So of course, some people make some silly mistakes here. You got to square the whole damn thing. Yes? Do you start to see why it made sense for me to pick a 3 here? Because what can I do now? Like some people might look at this and say, what the shit am I supposed to be able to do with that, Jeff? But isn't there, what can I do with the 9s? I can factor them out. And then of course, what's the square root of 9?
3.
That's insane. Square root of 9 is 3. And what's 1 minus sine squared? Bless you, listen to me. Bless you, my burper. Okay. And now a really interesting question about this. What's the square root of cosine squared? And it should really be the absolute value, but we take the positive, we're fine. So we were able to simplify that down quite a bit. Yes? So what that tells me is, if I have this type of thing sitting inside of a integral, if I replace x with this, it simplifies quite a bit. Okay. I don't want to take one. If I just make one up, it probably will be horrendous. But let me see if I can find one that's sort of like that we can try out right now. Blah, blah, blah. Oh, perfect. That one would even be better. So let's look at this here. I like this one for a few reasons. And by the way, if they ever just say integrate this, and U sub works, if I were you and it was U sub. If I say integrate using trig sub, then obviously don't use U sub. Would U sub even work on this though? If you were suddenly math god and I let you change the problem, what's one thing you could change to make U sub work?
X.
Make the top just x, right? Okay. So if the top was x or x cubed, do you guys all realize if it was x cubed, U sub would work?
Yep.
Okay. But it isn't either of those. Damn it. Now, I also want to point this out. Because the first step in this section is going to be which trig function do I substitute? That's the whole thing now. Why do you think a substitution of sign works here? Like, why did this go anywhere? Because it ended up with 1 minus sine squared, correct? Mm-hmm. So I want you to notice something. Isn't this constant minus function squared? Okay. Stay with me. And isn't 1, which is a constant, minus sine squared, which is a function, isn't that a trig identity? So what if I had constant plus function squared? What is 1 plus tangent squared? What is 1 plus tangent squared theta? Secant squared theta, yes? Uh-oh. All right. So I really want you guys with me because this is the whole game, and of course I'm going to go over this again in a bit, and I got a little handout. It's amazing. But if I would have put a plus here, I would have wanted this to be tangent. So there's no guessing. There really isn't any guessing. It's the form of the thing. Since it's 9 minus x squared, constant minus function. Oh, that's 1 minus. I want x to be sine. If it was 9 plus x squared, I want x to be tangent. If it was x squared minus 9, what is secant squared theta minus 1? What's 1 plus tangent squared? Secant squared. So what's secant squared minus 1? Tangent squared. So if I saw x squared minus 9, function squared minus constant, I want x to be secant. I need you to see this. The more you know your identities, the easier it is to tell when to use which trig sub. Because it's just based on the form of the identity. There's no guessing here. That's the first level that students have trouble with trig sub, is like, when do I make it this? I'm just going to try and see, yes.
So is trig substitution that I get to choose?
You get to choose what trig to replace x with. Yes. And then what makes you choose a certain way is what form the thing is in. Which trig identity does it follow? So this one, of course, is constant minus function squared. That's like 1 minus sine squared. I want x to be some kind of sign. Obviously, what coefficient do I want in front of the sign? Or maybe not so obviously. What made this doable? What if I would have put a 2 there? That would have been a 4. Could I have done what I did next? No. So what coefficient do I want? 3. If this was a 16, 4. If this was a 7, square root of 7.
Yep.
I mean, what do you keep telling me? You keep telling me the square root of it. We're in freaking count 2. We can handle square root of 7. Well, we'll see. You guys with me? Is everybody really cool with that? Like, you can factor x squared minus 25. X minus 5, x plus 5. You could factor x squared minus 11. Yes, do it. Factor x squared minus 11. You could do it. You could do it. You could do it. Why did I say x squared minus 25 is x minus 5, x plus 5? Because 25 breaks into 5 times 5, yes? Square root of 25 is 5. So how do I factor x squared minus 11? X plus square root of 11, x minus square root of 11. Are you guys understanding? Why do we not do that in algebra or pre-calc? Because we normally want to keep things nice whole numbers, right? Nice integers. Okay. So be ready for this number to not be nice. Most of the time it's going to be 25 or 16 or, Okay, let me stop for a minute. I love you guys. So, this is so counterintuitive. But I'm hoping with this really became something nice. So let's see what happens here. So remind me, what do I want x to be? 3 sine theta. So then what is dx? What's dx? If x is 3 sine theta, what's dx? Don't overthink it, just take this guy's derivative. Yes, okay. That's almost too nice to believe. This is better than u sub, at least in one way. Because u sub, I have to kind of like solve the other way. No, this is just straight up telling me what dx is. I just have to plug shit in now. That's actually better. I replaced all my x's with 3 sine theta, and I replaced my dx with 3 cosine theta d theta. Isn't that nicer? Doesn't u sub have that extra little make me show up? So then you could put me on, god damn you du bullshit. Yeah. This is just, hey, you see dx? Put this shit there. Okay, maybe? I'm trying to show you, even though this seems like it makes things worse, there are some better things. And normally a lot of shit cancels. So let's see what happens. I don't even know where this is going. Wait, where did I get this from? Oh, thank God. I want to make sure it wasn't one that didn't work. Okay.
It works.
Yes. So if I put this in, what do I put up here? 3 sine theta squared. So it's 9 sine squared theta. Is that cool?
Yeah.
And dx was 3 cosine theta, d theta. Become a theta. And then down here I'm going to get, no, let me see. We already did all the work, yes? But you say to yourself, 9 minus 9 sine squared, take out a square root of 9. 1 minus sine squared is cosine squared, square root is cosine. What do you notice immediately?
The cosines cancel out.
The 3 cosine thetas cancel. So normally some stuff is going to cancel. Die. And then I can take my 9 out, and then I've got a very standard thing here. Let me stop for a minute. Isn't that better than you might have thought it was going to be? I mean, it seems so weird. Why the shit would we take x and make it 3 sine theta? Because I'm hoping that the function in terms of theta is easier, or in this case, is able to be done, the integral. What do I do now? How do you do that? Is it 1/3 sine cubed? No, it's exactly the mistake I was talking about earlier, right? What do we have to do? Power is 2 down high, so I want to reduce the power, right? Reduce the powers that be. Does anyone remember? Remember, cosine's an asshole, so he gave himself the plus sign, so sine squared is going to have the minus sign. So it's going to be 1 minus cosine 2 theta. I'm going to put the over 2 out there. Let me stop for a minute. I'm really hoping some of you guys are out there, you've never taken calculus before, this is the first time you're seeing this, and it's so counterintuitive. The choice we made for substitution is really counterintuitive. But now I've got an interval I could do. Isn't that crazy? I mean, I still remember the first time I saw this, and it really freaked me the shit out. And then I realized, wait a minute, what other kind of substitutions could I do? And that's a lot of integral analysis later, is just, what other kind of substitutions can we do? I mean, even more counterintuitive shit makes things really reduced to a nice form. Okay, well, we're not going to do any of that. Don't worry. Yes?
Do you mind writing the trig identity that we're going off of?
Yes. Let me do 2 things. Has everybody got this business? Okay. So I used this. And again, cosine's an asshole, so sine's power reduction has a minus sign. So let me rewrite I took the 1/2 out front. And now I can just focus on that interval. Okay, how are we all doing? This is so nice, because I mean, you can sink your teeth into this. Right? There's a lot of math that ain't nothing to sink your teeth into, so it's freaky. If anybody has linear algebra in your future, that's a really good example of something you don't always have something you can sink your teeth into. How do I integrate this?
Theta.
Theta?
Sine 2 theta.
Yeah, minus sine 2 theta. You can put a 1/2, yeah. Now, does anyone notice if I circle that, why you're going to lose? Why would you lose some points besides the fact that I'm evil?
We don't have x.
Good. The original problem was in the variable x. We introduced the variable theta to make it easier to do. Our answer has to be in terms of x, though. Shit. Where did theta first show up?
X equals 3 sine theta.
Good. So what's sine theta?
X over 3.
Good, right? Now, is that going to replace that with x over 3?
No.
Because it's talking about a different angle, correct? That's a completely different angle than that. But what is sine 2 theta? What's the identity is the word.
2 sine cosine.
Is that cool? Replace it with 2 sine cosine. 1/2 of 2 is 1. Don't I know what to put in place of sine theta now? How do I figure out what to put in place of cosine theta? There's 2 different things you can do. I normally go with the visual, or you could do the identity. What's sine theta? What parts of a triangle is sine all about? Yeah, if you like SOHCAHTOA, that's fine, even though SOHCAHTOA sucks. Sine likes y, so this would be the y side over the hypotenuse. So I know I can put here, because sine theta is x over 3. How do I know that? Because I said so at the very beginning, correct? What's cosine theta? What am I missing to figure out what cosine theta is?
A side.
Yeah, what's this side? Who helps us out? Old Greek dude. Actually, his followers. Actually, the Babylonians. We'll all be fine. What do I put over here?
1 minus x squared?
Almost.
Yeah.
Square root.
Yeah. Does that look familiar? Wasn't that a part of our original interval? That will always be, because the triangle comes from that existence. So it makes sense it's going to show up. So what is cosine theta? I'll leave this blank for now. Yeah, cosine theta is that over 3. I love it. Yes? And what's theta? What's theta? What's sine theta? X over 3. So what's theta? And I'm not asking for like 17 degrees or something. I don't know, because it's freaking x. Yes, arc sine or inverse sine of x over 3. So, if you're given a problem and you make a substitution that changes the variable, you better frickin' change it back at the end. Or change your limits if it's a definite integral way. You know? Every theta's got to become x, some function of x. So we took care of these 2. Bam, bam. This one becomes arc sine or inverse sine. Okay, and then you can clean that up a little bit. I almost don't care. Yes?
Can you explain again how the adjacent is square root of 9 minus x squared?
X squared, well, so the x squared plus a squared equals 9. Using the Pythagorean theorem. Yeah? So x squared plus this squared equals 9. 9 minus x squared equals this squared. This is the square root of 9 minus x squared. Yeah, just set up the Pythagorean theorem and solve it. Yes?
I still have to practice trig identity, so I just wanted to ask, is the 1/2 part of the trig identity that changes that to sine theta, cos theta? So it's that one, so I just...
So the 1/2, I pretty much always take it outside, because then it makes this much easier just to look at.
Bottom, there's a half sign.
Where are we at? Sorry?
There.
Here. Oh, because when you integrate this, the answer can't be this, because when you differentiate this, you get a factor of 2.
But then from
So I
going
gotta kill the
down,
factor of 2 by putting a 1/2.
when you go down, that 1/2 goes away with the...
Oh, from here to here?
Yeah.
Sine 2 theta is 2 sine theta cosine theta,
So it is part
and
of
1/2
the
of that is sine theta cosine theta.
Okay.
Okay, good. How are we doing? Yes?
Can you explain again at the very end where you got the inverse sine of the limit?
Oh, right here. How do I solve for theta? What do I do to both sides?
Inverse sign.
Yeah, every equation in the world you ever solved, you just applied the inverse over and over and over again, correct? Because I call it unburying the x. So in this case, to unbury the theta, I take the inverse sign,
Oh.
die. Yes, that's all. Just solving for theta.
Okay.
Right.
So I get a feeling that I probably should have done a few more steps on a couple of those. Because some of our trig identities aren't really there. I'm getting a feeling, possibly. Here, let's do another example. And then I've got a little handout for you to try some on your own. Let's do something different. There we go. Beautiful. You never know. I might actually do a homework problem. Don't get your hopes up. So of course, if I just said, do this, you should rule out U sub. Always rule out U sub, meaning if it works, do it. If it don't, then you go shit, right? By parts is definitely nothing you ever want to do with this, you agree? One chunk of this is the square root of, no. I really hope I don't have to use by parts. But since I see x squared minus 1 and my trig identities are squared trig functions, I think trig sub. Do you guys see that? So it's when I see something like x squared minus 1 or x squared plus 9, then I think trig sub might work here if U sub or by parts don't. What trig sub do I want to use?
Jan?
No, because what's the tangent identity? 1 plus tangent squared is secant
No,
squared.
like tans.
So I really want you guys to get this. It can't be sine, because sine would be 1 minus sine squared, and this is the wrong way.
No, I meant x plus tan. So I meant
No, x is not tangent. Because then that would be tangent squared minus 1, and that ain't shit.
Secant.
X has got to be secant. So let me do this. I haven't done this. I sort of talked about it. What's sine squared plus cosine squared?
1.
1. Because sine is the x side, cosine is the y. I'm sorry, sine is the y side, cosine is the x side in a unit triangle. So of course Pythagorean theorem would just say this. If I divide everybody by cosine squared, I get tangent squared plus 1 is secant squared. If I divide everybody instead by sine squared, I get 1 plus cotangent squared equals cosecant squared. And you can see the symmetries there. So none of those help me because this says x squared minus 1. If it said x squared plus 1, then it's in this form, isn't it? Then of course I would use x equals tangent. It says x squared minus 1. Shit. So why don't I just subtract 1? So I make this. So what do I want to let x equal so it mirrors this? What do I want to let x equal so it mirrors this? Secant. I need you to see this. Students don't like trig sub because they feel like it's guessing or they don't really understand how they know when to do what. It's literally just the form it's in. What form matches which identity? Then I know exactly what's set in there. So what do I let x equal again, sorry? Secant. Just secant, because the square's already there, right?
Yeah.
And I don't have to put a coefficient, or the coefficient's 1, because the number is 1, so they're going to match. If it was minus 16, I want to let it be 4, so after squaring, they match. Okay. Now go as far as you can. Keep going. What's the next thing you figure out? X is secant theta. You also need to know what dx is. Good. Keep going. Get as far as you can, and then I'll catch up to you. Oh, okay. No, nice. hopefully, all right, let me just do this.
It's fine.
Huh?
It's pretty.
No, I'm just trying to say, I'm gonna try to skip fewer steps here. Just generally, I think you guys agree, the less I write, probably the better for everybody, but let me try not to skip too many steps. So that's just me just blindly shoving everything in there, yes? Now I just hope that stuff cancels. Please, dear God, I got so much shit in there. So immediately one of the secants dies. Die. What's this become? Tangent, because the square root kills the square, right?
Yeah.
Inside becomes tangent squared, square root is tangent. And let me see if you guys are cool with this. That's tangent theta times another tangent theta. It's tangent squared. Secant cubed can come up top and be written as cosine cubed. Now how do those interact? How do those interact? What's on the bottom of tangent?
Cosine, so you can turn it.
And in fact, tangent squared's got a couple. You guys see how this keeps going? So this would be sine squared over cosine squared times cosine cubed. Two of them die. So then I end up with a relatively easy trig sub. I'm sorry, trig integral. Let me stop for a minute. So some Pythagorean identities, and then just basic sine, tangent, sine over cosine. You want to simplify as much as you can. And then you take stock. Yes?
How did you make the cosine?
Do it again, sorry.
Tangent cubed times cosine cubed, how'd you get the cosine?
Well, it's tangent squared, right? Because it's tangent, tangent, tangent squared. So you're cool up to this step? Tangent sine over cosine, so this is tangent squared is sine squared over cosine squared. Two of the cosines die.
I was just wondering how you brought the secant up and made it cosine.
Oh!
Just like that's simple.
Secant is 1 over cosine, so 1 over secant is cosine.
Okay, sorry.
Yeah, you're good, you're good. Don't feel bad, I'm sorry. When you're in Calc 2, you're worried about all the new Calc shit, and then sometimes you sort of forget the old shit, yeah, okay. That's so understandable. Now listen, I keep saying this today, as if you didn't know. You're in Calc 2. What do I do now? And this problem is long. And what am I about to do? What do I need to do now? A U sub. In the middle of a trig sub, but who cares? Who gives a shit? I don't give a shit. I'm going to do my little U sub right now, bring it back to theta, and then I can finish it up like we did before. Not a big deal. So what am I going to let U equal here? You can see your du already, yes?
Yes, sine.
So U has to be sine, so du is what it is. So what's that? Yeah, U cubed, and U was sine. Yeah. Why am I not? Is everybody? Let me stop for a second. Is everybody cool with that?
Yeah.
I did a couple steps. Are you guys with me? But you should be at the point where you do a U sub. Don't rewrite 1/3 U cubed. Just rewrite 1/3 sine cubed because you know U is sine. Why am I not done?
X terms.
Because this is evil stuff, so of course I'm not done. But more specifically, I need to get it back to x. What was the relationship we identified between x and theta?
X equals to theta.
Let me rewrite what we got. So we got. And we know from the beginning that x equals secant. Gonna draw a triangle from that? Is x over 1. Secant is hypotenuse over
Adjacent.
x side or adjacent, sure. I want to apologize now. I'm going to continue to shit all over SOHCAHTOA, but if you know SOHCAHTOA, you can use it. It's fine. So just don't listen to me. I'm sorry. So what's this side gonna be?
Radical x squared minus 1.
Yeah, good. Which again, oh sorry. Okay. So what is sine?
Radical x squared minus 1 over x all cubed.
Good. And that's fine with me. I mean, you could do some shit there, but not really. Nothing meaningful, so yeah, I would just leave it like that. That's crazy. How would you check your work? Easy. How would you check your work? Take the derivative. And I don't care how ugly it is, derivatives are always easier. You know this. You're in calc too? Thanks, Jeff. Okay, so let me give you this. Let me give you this, and I'll shut up for a little bit, thankfully. I want you guys to work together on this. One side is trig sub, the other side is the next section. Maybe don't look at that quite yet. Or I can't control you. You can look at it if you want to.
Do you think after
Yeah, we like touched over it, like it touched on my weakness. Partial fractions. Yeah, and algebra, my first semester I took algebra, and I remember this.
You ever taken algebra? I think I should.
I think I should have taken trig. I need trig.
It happened here too. Like, I don't know. I just don't have it memorized. I have to write it down.
Our professor gave us the trig identities last
Yeah.
I
semester.
think it might be a clash.
So we didn't
I'm
think.
getting my signs.
Yeah.
All right, guys,
And then
do this for me. Do number,
So basically.
do A and do B. And then we'll look at C together.
Oh gosh, okay.
B is the one I was telling you about before. You're gonna have a lot of fun with it. Yeah. And can you, just to point this out, can you guys see like part A? You can't do U sub. Because there's no X in front, right? Blah, blah, blah. So trig sub saves us. You're like, I didn't really want to be saved, but too bad. Okay. Oh, there you are.
Oh, you know, it's fine.
So, is everybody starting to pick up? And I put it here explicitly about how to pick the A.
so
And again, the point I was trying to make earlier about the square root of 11 and factoring whatever, it doesn't matter if this thing here is a perfect square. You're just going to pick the square root. So that's going to happen to you over here. Yes? So, I don't know if you know this, but you're in Calc 2. So we should be so fine with doing that kind of shit. It's just a number. Who cares? Okay, we care a little bit, but not as much as you should. So let's see. What do you guys let x equal here?
2 sine
2.
theta.
Sine theta. And I always hate like memorizing this shit. Of course I'm going to make it 2, so when I square it matches, so I'm able to factor. So if I know the motivation behind why this is true, it's less memorization and more just doing what makes sense. What's dx then?
2 cosine theta d sine.
Good, that's so crazy. So then I get square root 4 minus 4 sine squared. And then dx is 2 cosine theta d theta. And not to pick on anybody, but some of you guys lived the idea of forgetting to fully replace dx with all the stuff it is, yes?
Yeah.
It's one of the first mistakes people make. You wish that wasn't there, but there it is, too bad. This square root of 4 is 2. 1 minus sine squared is cosine squared. The square root of cosine squared is cosine. There's another factor of 2, Jeff. So this gives you a cosine times another cosine. So I think everybody I looked at pretty much got here. I skipped a lot of steps, so I'm really sorry. But does everybody see up to that point? Everybody I looked at got there. I really hope it makes sense. You can't integrate this. It's not a polynomial. It's more involved. It's a chain rule if I was taking the derivative. That's a really good thing for me to say. The derivative of this is semi-involved. Yes? It's a chain rule. So the integral of this has got to be harder than that. So I can't possibly imagine this is going to be easy to integrate. So what I got to do is I got to save myself. I got to use this crazy thing. And again, is everybody cool? If I replace this, I'm going to take the factor of 1/2 out. And I can just focus on the top of this thing. Become a thing. Okay. And I was telling people this on the side, real quick. What's the integral of e to the x? Holy shit.
That's the E.
What's the integral of e to the ax?
1/8.
Yes. If the inside is linear and the function is easy to integrate, I don't need u sub. I just got to kill the chain rule piece, the what I want to say. Kill the constant that wants to come out. I got to kill it. If it isn't there, I got to kill it, right? Maybe. So this guy, when I integrate him, well, this guy's easy. Thank you for being there. Cosine comes from sine, but the answer can't be this, because I got to kill the factor of 2 that wants to come out. I like it. You could do u sub, but that would just be extra writing for no reason. If the inside's linear, it shouldn't need u sub. Now I got to figure out. Screw this problem. I'll do it later. Sine theta is x over 2. So theta is, the inverse sine of x over 2. If I draw the triangle, sine is the y side of the hypotenuse. So I know everything about theta. I don't know shit about twice theta. Is everybody with me?
Yep.
Which is why I have to rewrite this. So far I've got 2 inverse sine of x over 2. If I rewrite this, this will be sine theta, cosine theta. Sine theta, I know. Yay. Cosine theta, I'm just missing this, and what's this?
4 minus x squared.
Good. So then I get 2 inverse sine x over 2 plus 2 times, where'd it go? There it is, x over 2 times square root of 4 minus x squared over 2. And then you can kill some 2's and whatever out here. Okay. Plus c. By the way, if you did this, look at my poor c's on the other page. If you put the plus c over there and you forgot to put it in the end, I'm going to take points off. You got your plus c, I understand. I will take points off if you miss the plus c several times. If you miss it once or twice out of a problem, out of a quiz with like 7 problems, I'm not going to take. But if you miss it every time, I'm going to take some points. Yeah. Okay, how are we doing? Bless you. So everybody get the ideas. Everybody get the flow of this. This is a very, like I said, it's counterintuitive. The substitution we make makes things worse at first. So I want to do a couple of the first steps on this guy. Because this one, okay, listen, I will admit, I made it really heavy on the rad too, just because. We have to be able to bookkeep when we do these kind of problems. The very first thing I would do if I were you, notice how all of these have just a 1 in front of the x, the x squared. So I'm going to take a rad 2 out. And this is a beautiful example of we don't give a shit if I'm working with a non-perfect square. It's not a perfect square too. I know what I'm going to let a equal. So, and what's the form here? It's function squared minus constant. So what trig function am I going to use? Secant. And what coefficient am I going to give it? It's got to be the square root of this. Zoom out, Jeff. Okay.
What?
Come back. Thank you. Stay? No? Come back again. Stay away. Okay. Is everybody with me? Now, listen, you didn't have to take the rad 2 out, but it just makes so much sense. Get that rad 2 out of the way. It's extra shit. Just get it out of the way. Keep going. Keep going. You don't have to, you could draw it up if you wanted to, I wouldn't, sorry. Oh, that's this guy. So if you replace that with this, and then it's over 2, so that does.
Sorry, I didn't mean to touch you.
Yeah, replace that with this, and then the 2. Yeah.
Would that just make it 2?
Oh, right.
If we're squared,
So yes, you can tangent,
Me?
yeah.
that would just be 2.
Theta,
Yeah.
tangent, theta,
2 secant.
wow, that's a big one. Wow.
What's the derivative of sine? So you don't have to have this. It's that, yeah, it's really easy, that's
Oh,
shifting gears for the sine and cosine. It's gonna get us. If I don't make that mistake anytime in semester, that'll be amazing, so.
That's a trigonometry.
Wait.
You can't apply a root into 1 minus 1.
No.
So you have to
Don't these
translate that
Yeah.
into trig, which you can pull out.
So in this situation, how do you?
Oh wait, shit. No. I did I messed it up. That's why.
So what you and you
No,
realize,
so it doesn't cancel
both have a common
And
factor
you're able to take the
of
Okay.
2, right? So
Oh,
what
wait,
was
no,
so what was it? So it was
oh,
Huh?
2
Yeah.
is minus 4 over 2.
square, theta,
What
minus.
he realized is,
Oh,
both
sorry.
have a common factor of 2. So 2 minus,
Okay.
that means
Yeah.
2.
2.
But then, when you pull out a number of this
Okay, wait, I'm here now.
out of the root,
Okay.
it's not just.
So these 2 cancel.
What happens now?
That's why he had
It's like square
Oh.
root of 50 is square root of 25 times
Oh
square
my
root of
god.
2. So the
Okay,
parts
okay.
that are on the root, each
And
one of
then-
them has a root on it.
So,
You can
I
cancel
can just
out.
do.
It can't escape
this
without being
by
taken square root of, yeah.
Square root of 2,
So that's when he got that. And, okay,
Secant
now I can pull out that.
this, minus the square root of 2. Is that allowed? Is that just what you
I
want?
like
Oh,
I think I got lost.
minus 2. Thank you.
Oh.
So then you pull it out.
I got lost and I got lost.
Do that, which is one secant.
Right?
Spiritually, it leaves
It's
us
just one
flat.
secant. Yeah, it's just one secant.
So you can't, so.
Then this would be,
Just be.
Yes.
Secant. Secant.
would this be no,
The actual fee, I didn't bring it up. because I
no,
didn't do
no,
it.
no, you can't, can you?
Okay, thank you.
My hand's cramping so much
No,
writing.
I will, also, I will say, I got some of the parts.
I got some homework.
Yeah, I was completely screwed up.
Woo!
So I.
That's part of the
Want to
process.
celebrate?
Our son was right.
So you can't really take this
Now I feel
out.
like. Oh, it's like, I got that.
That looks good. And then
The
Yeah,
2.
trying to, I read off every
There we
step.
go.
that looks good.
And I wasn't
Can you?
listening.
Okay.
So I just.
I don't know.
That looks good.
Okay.
And I'm like,
Well,
So you have this.
No, wait, you did this right here.
Mhm.
Inside the
Where the square root comes
inside the radical.
And just,
Okay.
And then you can
Oh,
secant
wait, wait.
squared
And then what's
minus
secant
one
squared minus
sine.
1?
I just don't think I wrote it.
And now
That's
that
secant squared
you
minus 1.
separate,
Tangent square.
so much better than
Square root of
square
that.
minus
What's
one
tangent?
tan, so you have tan squared
jumbling.
square root, so they cancel,
Yeah,
you're
this,
just gonna
this,
have tan.
this really does feel like we just keep it
Theta.
back like 10 strokes.
And then the square root.
For me, what I do is when I'm doing
Wait,
the trig,
okay.
I'm finding my
Let me
theta,
try to write it
finding
down.
the sine, and I just kind of leave it alone.
Wait, so can I get rid of, I can get rid of this, right? I can get rid of that. Then I can get rid of that.
Well, you can't. You go ahead and
So we're focusing on the radical.
Oh.
And right now, inside the radical, we have two
Because it's temporarily going to
One
be a
mistake
trig problem.
Squared
is
theta
Once you
minus
change
2.
the variable,
minus two.
because
Okay.
it's trig,
So we factor out the
you gotta
two.
stuff it back
So
to
now we
side.
have secant
This needs to
squared
be
theta
That's
minus
why I'm
one,
always doing
and then
the
that
right
times.
first,
Okay.
and then I'm doing
Now
the
this
trig
is
after.
tan, so right now we have tan squared
How do I
theta.
turn you into something?
Because that's the trig identity.
Oh, okay.
And then we just square root both of them, so these cancel, and then that would be radical to tan.
I guess I could take you, no.
It's just the trig identity.
Yeah.
That's how things disappears in.
But then sometimes it also means that.
Wait, so what can I do to transform the tangent squared into something?
And now that's where I am. Oh!
But wouldn't the
Sine square
integral
over
times?
cosine
No,
square,
no,
that
it's not
doesn't
the
help,
equal
does it?
times
No.
versus.
Then it equals
I know that
the
there were
secant square minus one, that doesn't help.
So why,
Then it could be
why do we
10
sometimes
times
do
10,
that?
that doesn't help.
And then we like
Whatever.
use it and then we multiply by
What I think would work, but it's like a long step, would be
Yeah.
sine
I
squared,
just don't, I don't.
and then do the double
So
angle.
then why would
And then for both of them,
Right
yeah,
now,
and a
Yeah,
bunch of algebra.
something.
A bunch of algebra. So let's see if we can do that. So sine square, okay, we can do the bottom. So the bottom will be that 1 plus cosine
And now that is
theta
telling you,
over 2. And then the top one is
I'm
over 2.
gonna have to integrate
For
this
which
first.
one? The double angle.
That dx
Double, oh, shoot.
one dimension
It
doesn't really make a lot of sense.
Times the x.
These are not derived.
I just took out
That is
Okay, why say
sine squared.
I have
this step and I don't understand why.
theta, d theta left.
Because we're undoing differentiation, that's why. So, it's kind of saying.
So you get the integral of the function. and multiply that by the
It's not there.
Mr. Walter?
Real quick,
Okay.
I'm overhearing a conversation,
Yes.
and it's kind of related to something I was talking to somebody else about earlier.
Yeah.
This integral symbol is the first symbol we've ever seen. That is one symbol. This is one symbol. That's why when I do this, that disappears also, because that's not a this also. That's one thing. So I look at this as the first function we've ever seen that's like a bookend function. The integral symbol and the dx are bookends, and the function inside is what they're both attacking. Yes? Now when I substitute and I change what this is, like if this became 2 cosine theta d theta, now the bookends are this and this. Sorry. Keep up. Yes?
Yeah.
Okay, maybe. So I overheard something, and somebody else I was helping with earlier, I wanted to talk about that, but I forgot. So, is that all right? Sorry, I didn't mean to interrupt. Let me catch up to you guys a little bit, make sure everybody's on the right track. What's the next thing I do after this?
Derivative, yeah.
Yeah. And what's that going to be?
Radical to secant theta.
Theta, tangent, theta.
Yeah.
All right. Edge of the paper is really killing me. And then, okay. So now I should also do what?
Change
Because what are these all about? What can somebody tell me exactly what these represent?
the limits. Wait.
Be more specific.
What the function does when x reaches that number.
Not what the function does. No. Oh, I am. Okay. What do these
What
mean?
y is when x.
No, not what y is. These are what that variable is doing.
Oh.
What we are. Let me say that again. That is the way to look at this. Isn't this the integral from rad 2 to 2 on the x-axis?
Yeah.
So I'm on the x-axis because of what this says. If I change this variable, I can't leave these numbers here because now the new variable is probably doing something different.
I see.
And really quickly, I don't have time to do it in here, but what we're really doing when we change from x to u, if I had a triangle and then an area of something and I smush it, just smush it. Doesn't it have the same area? I don't chop it. I really want this to be, have a triangle, and then I smush it. Want to get taller if I smush it?
Yeah.
Isn't it going along a different part of the x-axis now? Isn't the area the same? So when I go from x to u, I'm literally smushing it or pulling it and making it become something easier to integrate. The area stays the same, but where I'm going from to changes, because now I'm smushing it or pulling it. Does that make sense? I could also translate it, but I may go where. Is that all right? Okay, so can somebody help me out? When x is rad 2, what is theta?
Right, 2.
What does theta have to be? If x is rad 2, I can divide rad 2. Secant of what is 1? Yes, I heard it. Secant is 1 over cosine. 1 over cosine is 1, so cosine is 1 when is cosine 1? What angle makes cosine 1?
0.
0. If you knew, instead of SOHCAHTOA shit, if you knew cosine likes x, then when I'm at 0 degrees, I am on the x-axis, cosine's happy, he's the biggest he could be. When I'm at 90, As I go to 90, he shrinks. The x piece, the x shadow gets smaller and smaller until it's got nothing. He hates it here. He hates it. Poor little guy. Yay, sucks. Yay, sucks. Sine, other way around. Yes? Okay, so cosine of 0 is 1, so therefore secant is 1 when theta is 0. So this new integral is going to go from 0. What if x is 2?
5 or 3.
Yeah, then I get 2 over rad 2 is secant. Rad 2 is secant. Rad 2 over 2 is cosine. That would be,
Yeah, 5 or 4.
what is cosine pi, rad 2 over 2?
5 or 4.
Pi over 4. Okay. So trust me. And you're like, well, if they can't do that, that sucks for me. But there are ways to do this. In fact, when I took this class, I never changed the limits. I would have put them in parentheses to remind myself that they weren't what theta was doing, and then I would bring x back. And then I took Calc 3, and I'm like, damn, I wish I would have done more limit changing. Calc 3 changes the limits like crazy. If you don't get basic practice now, you're going to suck in Calc 3. Now, if you don't have to say Calc 3, yay, or boo, or something. But you should still get practice changing the limits. It's just a good way to do things. What else do I get here? Let's see. X we said was rad 2 secant theta. Dx was, not dang it. And then this becomes, rad 2 squared is 2 secant squared. 2 secant squared minus 2. Here, Jeff, write some more stuff. Real quick, let's do a couple things. This whole shit dies, yes?
Yes.
Die. I can take a rad 2 out, put it with that, half a 2 times half a 2 makes a whole 2.
Yep.
And then I have secant squared minus 1 is tangent squared of tangent squared is tangent times another tangent, tangent squared. Now. Oh?
Wait, what?
Yes.
Wait, how'd you get rid of the radical?
Take the rad 2 out, so I get secant squared minus 1. Secant squared minus 1 is tangent squared. Square root of tangent squared is tangent. Times tangent is tangent squared.
Okay.
How do I do this integral? Is there a power reduction formula? I don't care, because tangent squared sucks, yes? But what is tangent squared related to whose integral is easy? Secant squared. So,
Oh, just
Squared theta minus 1.
1.
and that integral is easy as shit. Yes? What's the integral of secant squared?
10.
Integral of 1,
Theta.
and I want to go from 0 to pi over 4, and then just shove that shit in there. I almost don't care. What'll it be? 1 minus pi over 4 minus 0. So it'll be 2 minus pi over 2, I think. Is that right?
Yeah.
If I plug a pi over 4 in, I get 1 minus pi over 4, so I'll be 2 minus pi over 2. If I plug a 0 in, these are both 0. So I believe it's 2 minus pi over 2, which is a neat result. Okay. Now, you have to tell me, and you should have told me sooner, but it's okay. It's okay if you didn't. Was there a step that we got lost on? Yes? No? Okay. This kind of thing happens a decent amount, yes? That's why you don't want to forget where your dx is, because sometimes it saves you. Yeah.
Wait,
How did you get the pi over?
Oh, here? Okay. When x is 2, okay, we do this. When x is 2, yes? And if I divide by rad 2, that's rad 2, yes? If I flip both sides, yes? And then if I rationalize this, now it should be a value I know the angle for. And that's where pi over 4 came from.
Absolutely. I'm here, Joe.
So the theme of the day is me telling you what class you're in. You're a accountant. So You know these problems have these multiple little side steps you have to go on, especially when you have limits on an interval. You have to do a little side work. Yeah.
So in this case, we wouldn't replace theta with x.
Do it again.
We wouldn't replace theta.
Beautiful. I either have to change the limits to match with theta. And the beautiful thing about doing that is I don't have to bring x back. And in this problem, do you see how that kicks so much ass?
Oh, yeah.
Because very often, or sometimes, bringing x back is actually the hardest part of these problems. Trying to figure out how to draw the thing and what the button and solving and inverse and that, right? So if I just change the limits and stay with theta, I don't have to bring x back. I don't have to draw a little triangle. I don't have to figure out. Does that make sense? With other problems, they kind of roughly are the same amount of work. With trig sub, I definitely want to change the limits and just stay with theta. The other way to do this problem is to keep the numbers here that work for x, but then I have to remember at the end, I got to bring x back and then plug in for that. And like I said, in these problems, that's a lot more work. You guys kind of with me? Sort of, not really, just for your job. Okay. So I just want to get an opinion about this. I think you asked me about these, right?
I can't, I won't say the, I won't say it.
And then you asked me, like, are you going to do this to us?
Yes, I
I'm
love
pretty sure I told you.
Yes. Give me the paper, all I care.
So this one is, for two reasons, is not immediately obvious that this is a trig sub. First thing is there's no radical. So what I got to do, I have to remember to do this. 90% of the time, there's going to be this kind of stuff. But what really is important is that there's the inside. I could have a problem that's got a 3/2 power, or a 5/2 power, or whatever. You guys know with me? Isn't that still a square root with another power? So those could also be trig sub. Or I could just not have a radical. It could still be trig sub.
What?
Huh? What? What's wrong with you? Okay. So, for example, let me give you an easier looking example. If I had this problem here, I could do this with trig sub. There's no radical, yes? But it still has identity template to it, yes? Or I could do this problem with trig sub. Because I could still simplify the square root piece, and then I would have everything to the 5th power. Okay. This one is evil. Can you factor the bottom? I mean, you could. Do you want to? No. And that's where this kind of stuff might come in. If I could factor the bottom, I might want to do partial fractions. Don't worry about that yet. Okay. So what the shit, Jeff? What the ever-loving shit? So, here's the first step on this. You guys remember completing the square? Let me see if we can do this a more interesting way. Does anybody not remember completing the square? Okay, nobody, okay. So you take half the middle dude, right? What's half of -4?
-2.
And then you square.
4.
So that's what I have to add to make this factor nice, but I had +8, so I have an extra +4. So then how do I factor this? This is why we call it completing the square. The crazy thing is, what was the first step? Half of -4 is -2. That's exactly how the stupid thing factors. Yes? Does this sound familiar? Who knew completing the square was useful? I killed somebody. Oh, you're okay. Okay. Wait a minute. Here. Now we are. So we're used to x minus 2 is just a number I don't know. It's just like m. So this is trig sub. It's something squared plus 4. What trig would I want to use?
Tan.
Tan. So if I let, but now what do I want to let equal something tangent? Yeah, x minus 2 would be 2 tangent theta. And then I just do all the steps. Brute force.
So then would X still be on top?
Yes,
Okay.
it's gotta be. I haven't done anything to make that go away.
Yeah.
But now I could solve for x and put that up. So now what's x gonna be? 2 plus 2 tangent theta. That's gonna be on the top.
Yep.
Are there other ways to do this? Sure.
Wait, what's it?
It's up to you.
X
What do we got? We got some time. Sort of. No. Yeah, I do want to let us out early because I said we're going to take the break at the end of class. Is everybody cool with that? I just want to check in again. You guys cool if I end like 10 to 15 minutes early so that's our break?
Yeah.
Because normally I have to give you a 15-minute break in the middle. So I'm just going to give it to the end. Okay. So listen, I want you to look at the reverse. Has anybody ever done this stuff before? This partial fraction stuff? Yes, sir. I'm sorry?
I said I did this already.
Oh, you did the, oh, I'm sorry, yes. And then you also? You did this in Calc 1? Wow, excuse me. So if you've never done partial fractions before, we'll get into it next time. You can take a look at the examples I gave you. Otherwise, that's enough for today. We'll do that last problem next time, so if you want to take a look at it.
We usually go for algebra round.
Oh, our first quiz. I did set it, right?
Yeah.
Good, good, good. I can't remember if I had already said that. Yeah. Okay.
I understand the process.
Put it on Tuesday, right?
I don't remember.
Here we go. Yes. Use 7 by parts. So this Thursday.
Okay, also, I have a question, right? So you got 10 squared. Sorry? You got 10 from this one, right? But I thought I got 10 cubed of it. Can I see it work?
So this is tan squared. The square root of tan squared is,
Oh, okay.
and then you just get tan squared. Tan cubed would suck. Hello.
That you said you'd do next time? You said, so why is it x equals 2 originally?
So real quick, I'm sorry. If we had this instead, we would let x equal 2 tangent theta, right? Whatever's here, we would let it equal this.
Oh, so like whatever's being squared?
Yes.
Okay. Okay, that makes sense.
You're welcome.
And then also, would you mind if I took a photo of the homework? Just 'cause I don't have the book yet.
Oh, I put 7172 homework. I put scans in Canvas. Yeah.
So I came in late today because I had an issue with the vehicle. So I just wanted to let you know that.
Oh, okay. Thank you. You got the handout though, right? Did you not get this? Yeah, you must have. Yeah.
Yeah, I'm sorry. I just want to make sure I'm doing it right. So,
What's the matter?
is the homework?
Just gonna erase that.
Yeah, just the problems I assigned. Yeah, looks good. Yeah.
Okay, thank you.
I'm having trouble with something.
Yes.
I bought the textbook about 2 days ago
Okay.
through I bought it digital though.
Yeah.
And I'm having trouble accessing it.
Trouble accessing it. Who'd you buy it through?